Thank you very much for listening in today. My name is Festus Adedoyin. Welcome to this year's conference. And my keynote speech is about machine learning applications in energy tax and climate change. I will be presenting about the use of machine learning tools and their applications specifically in energy tax, which is an area that hasn't been covered a lot in the literature. Not many researchers are looking into the application of machine learning tools in trying to explore energy taxes and how they help in the fight in mitigating the environmental degradation. And the content of my presentation, I will talk extensively about machine learning applications, and I will also talk about environmental degradation, current solutions, the place of energy tax, and I will give some empirical evidences, some early findings from my research, and I would also make some points about the green future. And to start us off, I would like to look at the importance of energy tax and how it connects with climate change. So there have been several efforts to be able to manage the climate crisis. And one of the government policies is to be able to use energy taxes as a way to control emissions. So if you're able to tax companies more, if you're able to tax those who are responsible for environmental degradation more by increasing taxes, energy taxes, and specifically dirty energy sources like non-renewables, like fuel and other energy sources that increases environmental degradation. Perhaps that will help in the fight in the climate crisis. And so this is sort of the background when you consider how energy taxes have been brought in place to be able to manage the climate crisis. However, the application of machine learning tools to be able to understand the data in this area of energy tax and climate change is quite weak. There aren't many presentations, there aren't many research exploring neural networks, for example, deep learning tools, machine learning tools, to look at the data in a much more deeper way, particularly for energy taxes, and how its impact can be more presented. And so the current state of energy consumption and production is such that there is a move away from non-renewable energy sources to more use of renewable energy sources like wind, solar. There's quite a lot of investment in solar panels. So that is the current state. However, majority of the global population still make use of non-renewables. And that's why some government provide energy tax policies. For example, if you have an hybrid car or an electric vehicle, that way you have less taxes to pay. And some incentives by the government to be able to enhance environmental quality. And this is because of the continual struggle for the climate crisis to be resolved, for the ozone layer and the greenhouse gases to be reduced significantly. So these are the current debates, and everyone is finding a way to contribute to mitigating the climate crisis. And one of such efforts is the issue of energy taxes, governments using energy tax as a way to control and discourage people from using dirty energy sources, non-renewables. There are several challenges as well as opportunities in these areas, and some of which includes investment in renewables, maximizing the government policies or benefits that are available. These are opportunities when it comes to electric vehicle, electric cars, for example, or investment in renewables. And so we now think about the data. So when we look at this particular energy tax, how can we explore these stats? And that brings us to machine learning, the application of machine learning in this area. So machine learning is being used significantly. There are an increasing number of application of machine learning in the energy sector. And there are some use cases as well that are unique to machine learning. So, using machine learning tools and several algorithms to understand energy demand, to forecast or predict the direction of different energy sources. What particular energy sources would be used more in specific periods? So trying to understand what specific energy sources will be used more. So energy demand forecasting, machine learning has been used significantly in energy demand forecasting. There's also the use of machine learning in energy management. So when you think about how to manage different energy sources and how you want to understand what direction of investment and what sources. So there are some arguments using machine learning data from machine learning to predict the rise in electric vehicles. So if there's going to be a trough, if there's going to be an increase, if there's going to be a peak at some point in electric vehicles. So you can use machine learning algorithms to understand the data and make predictions very clearly. And that can be useful in how you manage different energy sources. There's also the application of machine learning in renewable energy integration. So when you try to bring in renewables into a particular region or a particular field or a particular application of energy sources, that could be in energy, in building, in household consumption of energy sources, several algorithms can help you understand how to integrate renewables in a mix with non-renewables. For example, there are some hybrid cars that uses petrol or diesel alongside electricity. So there are that level of integration, and machine learning can help us understand the data and make those predictions. However, there are challenges when it comes to energy tax policy. As I mentioned earlier, energy tax policies are being used to support the fight for the climate crisis, to manage the climate crisis more. However, there are challenges in administering these energy taxes. And so the application of machine learning can help in understanding the data and in making simulations, in making predictions, and trying to understand what specific direction should the government go when it comes to energy taxes. And this application of machine learning can include, tax compliance, if how well are companies ready to comply with energy taxes. What about tax fraud? How can you detect if there are leakages in the energy tax system? Machine learning applications, the use of very strong algorithms, several models in the machine learning application can help us to understand these areas, to detect these leaks and these problems. We can also use machine learning in energy tax optimization. So if we want to optimize the volume, if we want to optimize and understand what level of tax should we apply in specific areas. For example, in some cities, you can apply a specific energy tax and not get so much revenue, because there are, like in London, for example, there are so many areas where if you drive an electric vehicle, you don't have to worry about taxes, because these are places where it has to be emissions-free zones. So in that area, you could use machine learning to predict the direction of what nature of areas should you optimize tax, and what level of energy tax is much applicable. And that is in terms of the level of energy tax optimization. But there is also in terms of the machine learning, the use of machine learning in climate change, in the climate crisis. So there are areas where you talk about emissions reduction or even weather predictions. And in some cases, you could even use machine learning to understand disaster management and disaster prediction, for which the climate crisis is one of those. And overall environmental impact assessment. So machine learning algorithms are very useful in this application. And so apart from these areas, there are several benefits. Why should we use these machine learning tools? Because of efficiency, accuracy. We could have a lot more improved accuracy, whether with data, large volume of data sets, or even without data. We could make predictions, we could make simulations And that could actually make energy tax policy in terms of managing climate crisis much more effective, much more accurate. And that can also reduce costs because the government or policymakers do not have to waste policies or waste time in their fight for the climate crisis. There are challenges, and this is very important for my presentation in this conference. There are several challenges when it comes to the application of machine learning in energy tax and climate change crisis. One of which is data quality. So you struggle with data, especially in terms of measuring climate crisis, measuring energy tax. How do we measure it accurately and without having problems? So if you cannot measure energy tax accurately, that gives problem into the kind of data, and that also leads to more concerns in terms of putting in wrong data into a machine learning algorithm that gives you wrong predictions. So there are those challenges. There are also algorithm bias. So if I choose to use LSTM, for example, as a machine learning algorithm, somebody else wants to use multinomial regression, somebody else wants to use polynomial regression, and all of these different algorithms can have its own bias. And so we need to carefully manage ethics. How do we ethically apply machine learning algorithms in energy tax and climate crisis? So this is one area of concern that several researchers have pointed out to. In terms of looking at energy tax and climate crisis, there are existing models. So in terms of estimations, there could be, modeling the climate tax framework, but also predicting the impact of climate tax, energy tax on climate change. So there could be challenges with that prediction as well. And so we could go with the modeling way and then also use the predictions as well. For the modeling, there are existing econometric tools that have some machine learning built into it. That could be in form of pooled OLS, that could be in form of fixed and random effects, that could be in form of system GMM. Again, these are all different modeling techniques that could be used to model the carbon tax framework and its impact on the energy tax framework and its impact on climate crisis. But beyond the modeling, when you accurately get the modeling to establish the causal effects, then you can move on to make predictions, which then is very useful because then you could use supervised machine learning models specifically. Some may prefer to write unsupervised models, but in this case, you can actually use supervised machine learning models in making the predictions. And to jump into a specific case study, which I would run through for this research, we discuss environmental degradation. And again, as we mentioned earlier, we have a lot of compromised natural environments across the world. The climate crisis is very real. There has been a reduction in biological diversity in the overall health of the environment. And this degradation, this reduction in the quality of natural resources gives a lot of motivation for, there has been a lot of, urbanization, industrialization, the huge population. And so we see that there continues to be, land degradation, poor soil quality, water degradation, air degradation, the quality of the air we breathe in. All of these have, a mix of socioeconomic crises, institutional factors like governance, like politics, but you also have technological activities, you have cryptocurrency, crypto mining, a huge investment. We have quantum computers being built, a huge investment going into technological investment. All of this mix, gives us a challenge for the climate. And so there are so many solutions in terms of at the household level, we reducing consumption, you reducing consumption, engaging in recyclable activities. There are firms, trying to stop deforestation. The government also bringing the regulations in the form of carbon taxes or energy taxes. There's also the international community educating people, convincing people to talk about this and work towards it. But in terms of the government, this leads us to the energy tax, which my talk is about, and we'll walk through how machine learning can be used. So there are taxes being leveled on fuels, energy generation, transmission, or consumption, and it's a real source of revenue to the government. And But you also then have, for example, in the UK, there are environmental taxes. If you fly in the air, on the plane, there are mileages where you have to pay some level of taxes called air passenger duties, for example. And so there are arguments for the use of these taxes to be able to help, not just to generate money, but actually to also help the environment. And so we think about, energy tax revenue in the EU. If we look at it at Europe as a whole, that there are millions of euros that come in in form of energy tax revenue. And so we use these, and that can be, in form of, there are pollution taxes, there are resource taxes, there are transport taxes, and then energy taxes. And so, we look at these energy taxes. There are so many research that are trying to understand energy taxes using traditional data analytics tools. And that brings us to the need, to talk about the application of machine learning. And so we see that energy taxes are there, but they might not be effective. So how can we measure the effectiveness of energy taxes? How can we explore the effectiveness of energy taxes in the climate crisis? And one of those ways is to use machine learning tools to explore the data and make predictions in terms of the impact and make arguments for whether these taxes are truly useful or should be removed or refined or redefined in a way that it can be much more effective. And when we look at the nature of the data or the variables we bring together in trying to run the models, we think of carbon emissions as the dependent variable. And then we think of, the economic status in terms of real GDP. We think of the EU in terms of energy use. This is in terms of, EU energy taxes as well. And then we bring in tax dummies, and then we interact energy use with that tax dummy to be able to explore the impact of energy use on climate change or carbon emissions in the presence of taxes. How effective are these taxes to affect the impact of energy use on carbon emissions? So this is the model, and there are some early findings, from my research that gives us the data. So these are some results we have from the data. When we bring in robust standard errors, starting from very basic analysis, we think very carefully about, the models when you include energy tax, and that tells us of, the way energy use affects carbon emissions, but also the way energy taxes affect carbon emissions. As you would see, the numbers in red, they show us how energy use increasingly influences emissions in the EU. But we also see that carbon taxes are effective in reducing. So we have the blue, a highlighted blue element here, which says, minus 0.0977. So what this means is that a 1% increase in energy tax has a way of reducing carbon emissions by 0.09%. So if you're going to have 0.1% reduction in carbon emissions as a result of carbon taxes, I think that is a positive. So these early findings suggest that there is an opportunity for measuring the effectiveness of carbon taxes. But apart from that, we also think about the way other variables affect emissions. So when you capture energy tax dummy, that means when you look at the energy tax dummy and its impact on climate crisis or carbon emissions, it is also positive. So it means that at some point, you might have the use of energy taxes in some cases, when you cluster them, affecting carbon emissions positively. And so we think of a green future, and this is where, I begin to make a very serious argument for the application of machine learning in exploring energy taxes more. And so we think of a green future if the goal is to get to a green future with the use of energy taxes. When we consider complexities and all of the political problems in the world, the economic crisis, all of the happenings, we consider a serious investment in green technology. A serious investment in green technology can include putting more investment in solar, putting more investment in wind, in hydroelectric dams, which are all very safer for the environment, and these do not produce fossil fuel or waste byproducts, for example. It can power a home, it can power hospitals, it can be used to power schools, universities, buses on the road, trains, and so on and so forth, trams in the cities. And so a focus on the development of green technology can enhance the benefit of energy tax. So energy tax will serve as a penalty for not investing in renewables in some cases. Again, if we are able to explore several machine learning algorithms, as I've presented in this conference, then we might be able to understand its impact in the climate crisis. Thank you very much for listening to me. And I continue to make the argument that the climate crisis is real, but the use of machine learning applications, the use of machine learning algorithms has a capacity to help us understand the impact of climate energy tax on climate crisis a lot more. Thank you very much, and I look forward to your questions, your emails in the conference. Thank you.